Okay, let's do SAC2B number 2. If you haven't already read it, you might want to pause here and go ahead and read it. The important point, let's find out how much time it takes first so we know how to draw the time axis. 10 seconds there, and then another 20, so we're up to 30, then 35, another 5 makes 40, another 5 makes 45, so the time axis has got to go from 0 to 45 seconds. I've already sketched that on there for you, and I'm going to start as usual with the velocity graph. That's the easiest one to start with, in my opinion. And get back to the problem. It starts at rest, so it starts off with 0 velocity. That'll be in the position part, and begins to accelerate uniformly in the forward direction, getting up to 25 meters per second in 10 seconds. So let's mark off 25 meters per second. And that's how fast we get going in 10 seconds, and steady acceleration, so it's a straight line up to that point. I'll label it S for straight in case you can't tell by the drawing. And get up to 25 meters per second at the end of 10 seconds. Continues at that speed for 20 seconds. Let's go straight across at 25 all the way to 30. Nice straight horizontal line. So this line is not only straight, but it's horizontal. Label it S, comma H for straight, comma horizontal. And then what? The driver applies the brakes and slows smoothly to rest at 0 meters per second at the end of 5 seconds. So that would be right here. We're up to the 35-second mark. We've got a line that's straight down to 0. Negative slope indicating decreasing velocity. Negative slope means negative acceleration too. We'll use that a little bit later on. Then the car accelerates uniformly in the backward direction until it gets a speed of 10 meters per second in reverse after 5 seconds. So we're going to go, that's 25, and we're about 10 would be about up that high, so we'll go to about here. Accelerates uniformly in the backward direction. So it's straight line segment in here with a negative slope and winding up at a negative 10 meters per second velocity. And then the driver immediately applies the brakes and comes to a stop after 5 seconds. So again, 0 velocity at 5 seconds, going backwards, but slowing down how fast one is going backwards. That's actually a forward acceleration, a positive acceleration. We see with a positive slope there. And again, that line segment is straight, and the car winds up at rest. Okay, working from that, we should be able to get the acceleration, get a positive slope view. That means a positive acceleration. If somebody needed you to label key values, and I very often do say label key values. Increase of 25 meters per second in 10 seconds, that would be up here at 2.5 meters per second squared. Might as well label that. And then 0. Okay, velocity is staying the same. That means how fast the velocity is changing is just 0. So we got a straight horizontal line here. And if you wish, you can draw the vertical line connecting those two. And then we get a negative acceleration. Actually, we're dropping down 10 meters per second in 5 seconds. That's an acceleration of -5, so I gotta go twice as far below the line as I was above the line over here, so that'd be about right there. And this is straight, comma, horizontal. This is straight, comma, horizontal, straight, comma, horizontal. And at the end of that 5 seconds, we jump up to a positive acceleration of 2. We actually jump up 2 meters per second in 5 seconds. I'm sorry, 10 meters per second from -10 to 0 in 5 seconds. So that's an acceleration of 2 meters per second squared. I'll put that on there. I'm not labeling all the key values. I want to keep this screen cam kind of short. And I went too far with that. The observations end right there at the 45-second mark. So there's the acceleration versus time, and then position. To get the starting position, we're going to read the question again, or at least look at it. Starts out 25 meters ahead and then goes forward from there. So let's call that the 25 meter mark. And the velocity is increasing in value. We're getting higher and higher on the graph as we move over to the right. So the velocity increases with time. That means the slope of x versus t has to increase with time. That's a diagram that's going to be curving upward. And then we get to the slope at the 10-second mark, which is 25 meters per second. And it stays at 25 meters per second. So over here curves up. Maintain that slope, same slope at the end there, for 20 seconds. So this line segment is straight from there up to here. And then we get a decreasing slope down to 0. So I want to curve this up a little bit more. It was supposed to be curved up. Curved up in there. So it starts out with on the horizontal there. At the very end there, it's horizontal, and then curved up in the meantime, and achieves some slope at the end of that 10 seconds. Goes straight up from there to 30 seconds. So I'm changing the scale of my x-axis a little bit because I got room actually. And now it's got to flatten out. The value of v drops down to 0, and that means the slant has to drop down to 0 at the 35-second mark. I think I've gone a little past 30 here, so I'm going to erase a little bit and then have it curving downward. Achieving 0. Slant, 0 slope at the 35-second mark, and then we start getting a negative slope. So we're continuing to curve downward, but we actually got a negative velocity. That means that the car's backing up. So at this point it's got 0, and then it starts backing up, still more downward curvature here. That's a little too much because I got it steeper than before, whereas it's backing up at a slower rate than it was moving forward. So that's a little bit better. Yeah, there we go. If I can erase the bottom one and leave the top one, I'm probably alright. Nope, not going to happen. So we're still curved down in here, and then the curvature got a big negative value for V, and then it goes towards 0. So we got to get the curvature towards 0 here. Now in this segment it's curved up. I shouldn't say the curvature, the slant here, the slope. So for it to arrive at the horizontal right there, we've got to be curved up the whole way from there to there. And curved up, and then a straight segment, constant velocity, curve down while it's slowing down, curve down and actually going down because the car is backing up, and then from 40 to 45, curved up, and eventually the slope comes in flat in that we got 0 velocity at the 45-second mark. Okay, that does